All right, we are talking about double digit and triple digit, really multi-digit division with partial quotients. So a brief review on partial quotients is where basically a quotient is the answer from a division problem. So let's do a quick simple one. Let's do 29 divided by 9, okay? And when we do partial quotients, we just set it up similar to a division problem, but a long division problem, but we've got this little line on the end that extends. And we see first how many times can the divisor go into the dividend using friendly numbers, numbers that are really, really easy to multiply. So I could do 9 times 3. I know 9 times 3 is 27. I subtracted 27 from 29. I get 2, which becomes my remainder, and my answer is 3 remainder 2. So that's a quick sort of refresher if you already know how to do partial quotient division with smaller numbers. But now let's get into the big numbers. What if you have 100 divided by 14. Oh boy, how do I do that? It's a big problem. Well, and we're not working with decimals, but we will show how to do. I actually really love partial quotients with decimals. And so we're going to get to that for sure. Maybe not in this video. Probably the next one. Actually, you know what? I want to make the divisor a different color. I don't like that for. Okay, so remember, we are working with our friendly numbers. Friendly numbers are 10, 100, 5, sometimes 2, and then other numbers that we can easily multiply by. So the first thing I'm going to say to myself, okay, 14, how many times can it go into 100 using my friendly numbers? And I think 14 times 10, well, that's too much because that's going to leave me with 140. So we can't use 10. We got to go smaller. Well, 2 is a very friendly number. I'll just start there. I'll do 2. 14 times 2. Well, that's 28. And then I subtract. Well, I guess I'll do it the traditional way for everyone who wants to see things really clearly. I subtract 28 from 100 and I get 72. You can see that that's 72. You know what? Let me fix this 7 so that it's clear. I'm having problems writing today. 72. And then I'm just going to keep adding 2. Then I'm going to keep multiplying by 2. 14 times 2. Again, that's 28. And then I'm subtracting 4. So we've got 44. And let's just keep going down this road. 14 times 2 again is 28. As long as this number here is larger than this number, we can keep going. We can keep going and keep finding partial quotients. Okay. Okay, so now I'm at 16. I know I'm very close. And I know 14 can go into 16 one time. 14 times 1 is 14. And now I'm left with 2, but 14 cannot go into 2. So I've got my remainder. I have got my remainder, and all I need to do is add this column on the side up. I'm going to add up all these numbers. 2 plus 2 plus 2, well, that's 6, and then I add 1, and that's 7. Oops, wrong color. That's 7. So my answer is 7, remainder 2. Or we could also say 7 and 2/14. That is my answer, and I solved the problem. Let's do one more just for kicks. Let's try to find some large numbers here. Let's do, let's do 9. Oh, let's do something exciting. Let's do 9,000 and 9,010 divided by 4. No, let's do divided by a larger number. Let's do divided by 15. Oh my goodness. That looks a little bit of a headache, doesn't it? Now, a problem like this, I much prefer using partial quotients rather than traditional long division. I used to like long division more, but the truth is that I find that long division it's people are more prone to mistakes using long division. That's just my opinion here. And so I prefer using partial quotients. So I have 9,010 divided by 15, which I'm going to put in another color. And I really need to use my friendly numbers today, definitely for this problem. Well, let me think. Okay, we've got friendly numbers. Let's think we've got 10. 15 times 10 will be 150. Well, that's really far from 9,000. I want to go higher. What about 100? Well, 15 times 100 is 1,500. That gets me a lot closer. So that means, what if I do I guess I'll start there because I don't want to make it too confusing. I'll start with 100. 15 times 100 is 1,500, or 1,500, we could say. And just a little reminder, when we have the reason that is relatively simple to do is whenever you have a power of 10, like 100, you multiply the 1 by the number that's being multiplied, and then you just add then you just add these zeros on the end. And that's what makes them so friendly, these powers of 10. So let's do some subtraction. Okay, I still have a pretty big number, 7,510. I could keep multiplying by 100, or I could try to go a little higher to get to my answer a little faster. Well, I could do 200. Okay, now because I know multiplication, I know that 15 times 200, again, we're dealing with friendly numbers. Well, 15 times 2 is 30, and then I'm going to tack on these zeros at the end, which gives me 3,000. So I'll do 200, and now I've got 3,000. I can just subtract that now, and I'm still left with 4,510. And I'll do another 200 because I know that'll fit. So far, so good. And now I have 1,510. This is great because I know that 15 times 10, 15 times 100 is 1,500 or 1,500. And now, what do we notice? We notice that 10, because I'll put the zeros there, we've got, you know what, actually, let me move this out. We've got 10 as a remainder because 15 cannot go into 10. And now comes the fun part, the very last part. I'm going to add all these numbers on the side. Can't really fit a plus sign, but let's do it. Here's 0. And then I add 1 plus 2, that's 3. 3 plus 2, that's 5. 5 plus 1, that's 6. And what's my answer? 600 remainder 10, or 610 fifteenths. Fun. Are we having fun yet? I know it's a lot to take in. And so I'll stop there. Partial quotients, it all works this way. You can have really long numbers, and you just keep using these friendly numbers and use these partial quotients, add them up, and you will get your answer. And soon we will learn how to do this with decimals, which is super exciting. Till next time.